In Part 3 of the Unit 2 notes, we will be covering classification of matter. An element is a pure substance that cannot be broken down into simpler, stable substances. They are made up of only one type of atom. Notice here we have bolded type. Our examples are aluminum and oxygen, but if you look at the actual symbols, while aluminum has just a single Al, oxygen is O2. So just because we have a subscript here does not necessarily mean that it's a compound. If there's only one type of symbol present, it's going to be an element. Which brings us to our second term, atom. An atom is the smallest unit of an element. So a single oxygen present within an O2 would be an atom. Or I could say that there are two atoms present within elemental oxygen. A compound is a pure substance that can be broken down into simpler substances through a chemical reaction, and they are made from two or more different elements. So an example there would be water, which is H2O. So we have two hydrogen atoms and one oxygen atom bonded together in order to make a compound. Next up, we have mixtures, and there are two primary types of mixtures that we're going to be talking about. A homogeneous mixture is a mixture which is uniform in composition on the scale of interest. The substance looks the same all the way through. Homogeneous mixtures commonly consist of a solid dissolved in a liquid, two evenly mixed liquids or gases. So, for example, you could have something like Kool-Aid. So you have some type of sugar which is dissolved within water. You could have air, which is a homogeneous mixture of many gases, including nitrogen, oxygen, carbon dioxide, helium, and a whole variety of other gases in smaller percentages. You could have salt water, which is another substance which is dissolved within water, or any type of alloy, such as brass. So this is going to be an important word that you're going to have to know. An alloy is a mixture of metals that are mixed evenly at the molecular scale. So brass consists of two different elemental metals, copper and zinc, but they're mixed so evenly that they essentially make this new substance, an alloy. So for tests and quizzes going forward, you are going to need to know that any type of alloy is going to be a homogeneous mixture. So if I were to name an alloy that you might not necessarily know, so for example, maybe bronze, you might not have known that bronze was an alloy. I would specifically call it out as an alloy so that you can then identify it as a homogeneous mixture. So brass is the only substance that you're going to have to know is definitely an alloy, but otherwise I would say that it is an alloy in the question. A solution, a special type of homogeneous mixture which may exist as a gas, a liquid, or a solid depending on the state of the solvent. So I have a few examples here of types of solutions. I had mentioned air before. So air is a gaseous solution with nitrogen gas acting as a solvent. That is the gas that is the highest percentage within our atmosphere. We next have braces, which are made of nitinol, which is a solid solution of titanium and nickel. And finally, we have soda, which is a solution of carbon dioxide and sugar dissolved within water. So these are all examples of solutions. All right, so we had homogeneous mixtures. These are heterogeneous mixtures. Now, homo means the same, which is why for a homogeneous mixture, it looks the same all the way through. It's the same composition top to bottom. Hetero means different. So for heterogeneous mixtures, the composition is not uniform. You're going to have either different layers or you're going to be able to see the different pieces within this mixture. Typically consists of substances of varying particle sizes which do not dissolve within one another. So a couple of examples of this, we could potentially have sand in water. So we can see that we have our two different layers here with the sand on the bottom and the water on the top. If we're talking about orange juice, it would have to be with pulp. So things are floating around inside of it so that it's not evenly mixed completely. If you had something like chicken soup, you have the noodles, the chicken, the vegetables, which are all spread out within that liquid. And if you had something like granite, so you have the different types of little stones that are fit within the larger structure. So these would all be examples of heterogeneous mixtures. Under the umbrella of heterogeneous mixtures, we also have suspensions and colloids. So a suspension is a heterogeneous mixture containing particles that settle out if they are undisturbed, such as mud. Another example of this would have been that precipitate that we were talking about in a previous video. They could potentially be separated through filtration. We're going to be talking about separation techniques soon. A heterogeneous mixture for colloids in which the dispersed particles are intermediate in size between those of the solution and the suspension. So a good example of that would be milk. They cannot be separated through settling or filtration. Here we have a picture which shows the overall classification of matter. So from matter we have pure substances and mixtures. For pure substances, that could be further broken down into elements. So we have a single type of atom here, or a compound, where these are all pure substances, but each individual substance is made up of different types of atoms. On the mixture side, we could have a homogeneous mixture where everything is evenly mixed, or a heterogeneous mixture where there is this clear division or separation between the substances. Now, when you're asked to classify matter for the questions on my tests and quizzes, you'll have access to a periodic table, and you'll want to be able to use that to help you determine if something is an element or a compound. Now, an element is broken up by a capital letter and potentially a lowercase letter. If you see two capital letters next to each other, that means that they are actually two separate symbols. So in my example that I have here, this element right here, element 72, is hafnium. So we have the capital H and the lowercase f. But if I had a capital H and a capital F, that would mean that I had hydrogen and fluorine bonding together. So it's going to be important that you not only look at the letters, but you also look at the capitalization. Now, when you're looking at a mixture, you're going to end up seeing a plus sign within the formula. And from there, you're going to have to try to visualize what the substance would look like in order to determine if it is a homogeneous or a heterogeneous mixture. So for our checkpoint, we're going to be doing just that. We're going to be classifying substances as an element, compound, homogeneous mixture, or heterogeneous mixture. Now magnesium, we have a capital M and a lowercase g. That shows that this is a single symbol. And if this is a single symbol, it must be an element. For number 2, water plus sucrose plus salt plus other various components. Well, the fact that we have these plus signs in the middle means that it can't be an element or a compound. So it must be one of my two mixtures. And if you visualize Gatorade, you have all of these substances which are dissolved within the water. When you're drinking Gatorade, there aren't things, floating or settling down to the bottom. So this would be an example of a homogeneous mixture. Chicken Parmesan, you have the chicken, the breading, the sauce, the cheese. You have different layers. You can clearly see the differences within that example. So that would be an example of a heterogeneous mixture. All right, and finally, silver chloride. We have silver, which is Ag, and chlorine, which is Cl. I have two elements which are bonded together, which is why there's no plus sign in between them. So that shows that this must be a compound. All right, so for our final slide today, we're going to be looking at a chemical reaction. So if you're looking at a chemical reaction here, it could take a few different forms. You could see a word equation. So here it's says mercury 2 oxide, there's an arrow, and then mercury plus oxygen. So this is showing that this one thing is breaking down into these two separate things in the end, these two different elements. You could also potentially see it as a formula. So we have HgO representing the mercury 2 oxide, and then we have Hg plus O2 because elemental oxygen always has this little subscript of 2 here. It's a special type of element called a diatomic, which you do not necessarily need to know yet. So our reactants are going to be on the left side of this arrow, and our products are going to be what you're left with at the end. So they're going to be on the right side of the arrow. And that covers classification of matter. So when we come back in part 4, we're going to be looking at separations of mixtures or separation techniques.